Welcome. This is CIE 9709, May June 2011, Pure Mathematics, paper 12. So we shall try to solve. The first question is integral of x cube dx plus integral of x power minus 3 dx. So it becomes x power 4 upon 4 plus x power minus 2 upon minus 2 plus c. So you can write as x power 4 upon 4 minus 1 upon 2 x square plus c. That's going to be the answer. Question number 2. The terms x square and x cube, find the terms x square, x cube in this expansion. So I just write general term 6cr 1 to the power of 6 minus r minus 3 upon 2x whole to the power of r. As such, I want x square. So r value should be equal to 2. So it should be term in x square should be 6c2 1 to the power of 6 minus 2 minus 3 upon 2x whole to the power of 2. So simplify that, 135 x square upon 4. Next time I want x cube. So term in x cube. So r value should be 3, 6c3, 1 to the power of 6 minus 3, minus 3 upon 2, x whole to the power of 3. Use the calculator, you should be able to get the answer 540 x cube upon 8. Given that there is no term in x cube in this expansion, find the value of constant k. So what is that expansion? K plus 2x times 1 minus 3 upon 2x whole to the power of 6. So there is no term of x cube. So when there is no term of x cube, so k plus 2x should be multiplied with the term of x square and with the term of x cube. Why is it so? K should be multiplied with x cube and 2x should be multiplied with x square. So just now we have done x square is 135 x square upon 4, x cube is minus 540 upon 8. So k times minus 540 upon 8 and 2 times 135 upon 4. These are the possibilities of getting it out. X cube should be equal to 0. So 540k upon 8 minus is equal to minus 2 times 135 upon 4. So you can simplify this one. 4 times 1, 4 times 2, then 135 times 2 is 270, 270 times 1, 270 times 2, so minus k is equal to minus 1, so which implies k equal to 1, because we can see that 2 and 2 also gets cancels. Minus k equal to minus 1, k equal to 1. Question number 3. The equation x square plus px plus q equal to 0, where p and q are constants, has the roots minus 3 and 5. Find the values of p and q. So we know that x square minus x times sum of the roots plus product of the roots is equal to 0. That is a condition. So x square minus x times sum of the roots minus 3 plus 5 plus product of the roots minus 3 times 5 equal to 0. So x square minus 2x minus 15 equal to 0. Compare with x square plus px plus q equal to 0. So we can clearly see that p equal to negative 2, q equal to negative 15. P equal to negative 2 and q equal to negative 15. Using these values of p and q, find the value of the constant r for which the equation x square plus px plus q plus r has equal roots. X square plus px, p is minus 2x minus q plus r, what is it, should be equal to 0, should have equal roots. So what is a value over here? 1, b value is equal to minus 2, c value is equal to r minus 15. They should have equal roots. Equal roots means b square minus 4ac should be equal to 0. Minus 2 whole square minus 4ac r minus 15 should be equal to 0. So 4 is equal to 4 times r minus 15. 4 and 4 gets cancelled. This gives you r minus 15 equal to 1, r equal to 16. So what is the value of r? 16. Question number 4. A curve has an equation y equal to 4 upon 3x minus 4 and p 2 comma 2 is a point on the curve. Find the equation of the tangent. So first, to find the equation of a tangent, I have to find the derivative. 4 times this is 3x minus 4 whole to the power of minus 1. So minus 4 times 3x minus 4 whole to the power of minus 2. Chain rule, don't forget to multiply by 3. So then the slope will be, plug in the 2 comma 2 over here, minus 12 times 3 times 2 minus 4 whole square. So this should be giving you minus 12 times 6 minus 4 is 2, 2 square minus 12 upon 4, which is negative 3. So the gradient is negative 3. Equation of a tangent y minus y1 equal to m times x minus x1. So y minus 2 equal to minus 3 times x minus 2. So we get y minus 2 equal to minus 3x plus 6. So 3x plus y minus 8 equal to 0. Find the angle that this tangent makes with the x-axis. So slope of the tangent was tan theta, which is minus 3. Slope of the tangent is also given by tan theta, which is minus 3. So theta is equal to tan inverse minus 3. Use the calculator, you should be getting 108.4 degrees. Question number 5. Prove that the identity cos theta upon tan theta by 1 minus sin theta equal to this much. So cos theta, tan theta is sin theta upon cos theta times 1 minus sin theta. So this cos theta is multiplied upwards, so it becomes cos square theta upon sin theta times 1 minus sin theta. Then do the rationalization, multiply and divide with 1 minus sin theta, 1 plus sin theta. If minus is there, we multiply and divide with 1 plus sin theta. So what does that becomes now? Cos square theta times 1 plus sin theta divided by sin theta times a plus b into a minus b is a square minus b square, 1 minus sin square theta. 1 minus sin square theta is cos square theta. So cos square theta times 1 plus sin theta divided by sin theta times cos square theta. So cos square theta gets cancels. So I'm left over with 1 plus sin theta upon sin theta. Bifurcate, it becomes 1 upon sin theta plus sin theta upon sin theta. So which is 1 plus 1 upon sin theta. Hence solve the equation, this is equal to 4. So we know that this is equal to this. So this one should be equal to 4. 1 plus 1 upon sin theta is equal to 4. 1 plus 1 upon sin theta equal to 4. So 1 upon sin theta equal to 3. So sin theta equal to 1 upon 3. So theta equal to sin inverse 1 upon 3. So sin inverse 1 upon 3 is nothing but what? 19.5. Another angle, how do I get it out? 180 minus 19.5. So which is nothing but what? 160.5. So angles are 19.5, 160.5. The function f is defined that f of x is equal to x upon 3 upon 2x minus 1. Find f of x. F of x. F of x is nothing but what? X plus 3 upon 2x minus 1. F of x. So now in f of x, wherever x is there, I am going to substitute that fraction. So first, what am I doing it out? Once again, let us go slowly. F of x. What is f of x? F of x is x plus 3 upon 2x minus 1. So what does that mean? In function f, wherever x is there, I need to plug in this entire fraction. So it becomes x plus 3 upon 2x minus 1 plus 3 in the numerator, then 2 times x plus 3 upon 2x minus 1 minus 1. Now take the numerator LCM or the common denominator, 3 times 2x minus 1 upon 2x minus 1. Then 2x minus 1, 2 times x plus 3 minus 2x minus 1. I can see that 2x minus 1, 2x minus 1 gets cancels. So what am I left over with? X plus 3 plus 6x minus 3 upon 2x plus 6 minus 2x plus 1. So we can further see that 3 gets cancels, 2x gets cancels. I get it out 7x upon 7, which is equal to x. Hence or otherwise obtain the expression for f inverse of x. So hence or otherwise, it has been given that hence or otherwise. So we use it on hence. We came to know that f of x is equal to x. We also know that f of f inverse of x is also equal to x, because f and f inverse will get cancelled. So from here we can see that f of x and f inverse of x are same. So f inverse of x will be equal to nothing but what? F of x itself only, which is x plus 3 upon 2x minus 1. F of x is equal to x we have proved, but according to the formula f of f inverse of x is equal to x. So therefore the function is itself its own inverse. So f inverse of x is equal to f of x. Question number 7. The line L1 passes through a point 2, 5 and 10, 9. L2 is parallel to L1 and passes through origin. The point C lies on L2 such that AC is perpendicular to L2. Find the coordinates of L2. So L1, it passes through A and B. A is how much? 2, 5. B is how much? 10, 9. L2 is parallel to L1 and it passes through origin. The point C lies on L1, L2 and such that AC is perpendicular to L2. AC, so I take this one, AC is perpendicular to L2. So this is L2 and this is L1. Find the coordinates of C. So first of all, I find gradient of L1, which is y2 minus y1 by x2 minus x1, which is 4 upon 8, which is 1 upon 2. So gradient of L2 also will be 1 upon 2. Gradient of L2 is also 1 upon 2 because they are parallel lines. Now L2 passes through origin. So I can find equation of L2. Y minus y1 equals m times x minus x1. So what do I get it out? Y equal to 1 upon 2x. This is the equation of L2. Now perpendicular gradient for L2, because AC is perpendicular to L2, right? Perpendicular gradient of L2 will be equal to minus 2, 1, minus 1 upon 2 perpendicular gradient will be minus 2. Because it was 1 upon 2, its perpendicular gradient will be minus 2. Reciprocal and change the symbol. So I can find it out equation of AC. Equation of AC, because I know the point A is 2, 5 and the gradient is minus 2. So y minus y1 is equal to m into x minus x1. So y minus 5 equal to minus 2x plus 4. So I get 2x plus y minus 9 is equal to 0. This is equation of AC. And L2 equation was y equal to half x. These two intersect at which point? They do intersect at C. So I can do the simultaneous equation. So 2x plus y is nothing but what? Half x minus 9 is equal to 0. So 5x upon 2 equal to 9. 5x is equal to 18. X is equal to 3.6. Once x is equal to 3.6, plug in over there. 1 upon 2 times 3.6. Y equal to 1.8. So what is the coordinates of C? 3.6, 1.8. Next, find the distance AC. A is 2, 5 and C is 3.6, 1.8. So AC is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So which is 1.6 square plus 3.2 square, which is, do by calculator, 3.58. Relate to the origin, the position vectors of A, B, C are given as OA, OB, OC. Find the angle ABC. So B is the midpoint, so mid number. So I have to find BC and BA. How do I get it out BC? BC is OC minus OB, second vector minus first vector. 10, 0, 6 minus 4, 2, 3. So which is going to be 6, negative 2, 3. BA, second vector minus first vector, OA minus OB. OA is nothing but what? 2, 3, 5. OB is nothing but what? 4, 2, 3. So minus 2, 1, 2. So I find cos ABC is BA dot BC by modulus of BA and modulus of BC. So what does that becomes now? Minus 2 times 6 plus 1 times minus 2 plus 2 times 3. I times I, j times j, k times k. Modulus of BA will be square root of 2 square plus 1 square plus 2 square. Modulus of BC 6 square plus 2 square plus 3 square. So that does becomes as minus 12 minus 2 plus 6 upon square root of 9 and square root of 36, 34, 49. So it becomes minus 8 upon 3 times 7. So minus 8 upon 21. So ABC is equal to cos inverse of minus 8 upon 21. Do by calculator, it should be giving you the answer 112.4 degrees. Next part, point D is such that ABCD is a parallelogram. Find the position vector of D. ABCD is a parallelogram. So we shall try to draw the parallelogram. A, B, C, D. A, B, C are been given, A, B, C are given, D. So what is that is, there it is a parallelogram. In a parallelogram, diagonals bisect each other. Midpoint of AC should be equal to midpoint of BD. So AC divided by 2, midpoint of AC should be nothing but what? OA plus OC upon 2 should be equal to OB plus OD upon 2. So OA, what is OA? 2 and 2 gets cancels. So I get it out OA. OA is 235, OC is 1006. 235 plus 1006 should be equal to OB. 423 plus XYZ. So XYZ will be equal to 2 plus 10 minus 4. What is this one? 2 plus 10 minus 4? 2 plus 10 minus 4. Next one will be 3 plus 0 minus 2. And next one will be 5 plus 6 minus 3. What is this 5 plus 6 minus 3? 5 plus 6 minus 3. And 2 plus 10 minus 4 is this one. And we may use another color. 3 plus 0 minus 2 is this one. So I use the color coding, easy to understand. So it becomes 8, 1, 8. This is OD. Question number 9. The function f is such that f of x is equal to 3 minus 4 cos to the power of kx, where x lies between 0 to pi, where k is a constant. In the case k is equal to 2, find the range of f. So f of x will become 3 minus 4 cos square x. We know that cos square x, maximum value is 1, minimum value is 0. So therefore, one of the limit will be 3 minus 4 times 1, which is minus 1, 3 minus 4 times 0, which is 3. So the range is minus 1 to 3. Range is f of x. Is it f of x? Yes. F of x lies between minus 1 to 3. The exact solutions of f of x is equal to 1. So 3 minus 4 cos square x is equal to 1. 4 cos square x is equal to 2. So cos square x is equal to 2 upon 4. Cos square x is equal to 1 upon 2. Cos x is equal to positive 1 upon root 2, or cos x is equal to negative 1 upon root 2. So x is equal to positive 1 upon root 2 is 45 degrees, negative 1 upon root 2 is 135 degrees. But I think so it is given in radians. So therefore, what am I going to do? I am going to write it as pi upon 4 and 3 pi upon 4. That's going to be the answer. Next, in case k is equal to 1, sketch the graph y equal to f of x. So k equal to 1. So y equal to what does that becomes? 3 minus 4 cos x. Does that becomes 3 minus 4 cos x? Sketch the graph. So first I'll draw for y equal to cos x. So it should be in this way. 0, pi upon 2 and pi. I want only up to pi. Cos x, 1 and negative 1. Now I want for 4 cos x. What can I do? I can copy this one and make them numbers as 4 and negative 4. Now I want for y equal to negative 4 cos x. What can I do? Upside down. Do it out upside down. So this will be negative 4 and 4, 0, pi by 2 and pi, 0. Next I want 3. Y equal to 3 minus 4 cos x. So move this graph 3 units up. So what will be my final graph? This goes 3 units up. So this will become negative 1 and this will become 7. That is what negative 1 and 7. This is going to be sketching the graph, and we need not show. So 0 comma negative 1, and whenever it is pi, it is 7. So these 2 points are sufficient enough to show it out. So what we can do, I want only this particular graph, the red color one. So no other part, you can erase it out, the other part. Next, what else is being asked? State a reason why whether f has an inverse or not. So our graph, what was our graph? Again, we had a page, if you remember. So our graph was like this. So negative 1 to 7. You can see that it is a 1, 1 function. So only if you draw a horizontal line, it is intersecting at only one point. So as it is a 1 to 1 function, 1, 1 function, it has inverse. Only 1, 1 functions will have inverse. It has inverse. That is the answer. Now we shall go to the next question. So 10th question. A circle is divided into 6 sectors in such a way that the angles of the sectors are in arithmetic progression. The angle of the largest sector is 4 times the angle of the smallest sector. So, first sector is A, second sector is A plus D, angles A plus 2D, A plus 3D, 6, 1, right? A plus 4D and A plus 5D. So, the largest one will be A plus 5D and the smallest one will be A. What is he says? The largest is 4 times the smallest is equal to 4A. Given that the radius of the circle is 5 centimeters, so radius is equal to 5. Find the perimeter. A plus 5D is equal to 4A. Now, the angle of the largest sector is 4 times the angle in the smallest sector. Given that the radius of the circle is 5 centimeters, find the perimeter. So, we know that sum of all angles is equal to 360 degrees, right? Sum of all the angles, because angle at a point is equal to 360. So, we can use formula n upon 2 times first term plus last term. So n is nothing but what? 6 upon 2. First term is a and the last term is a plus 5d. Should be equal to 360. So 3 times 2a plus 5d is equal to 360. So 2a plus 5d is equal to 120. From here, the condition has been given as a plus 5d is equal to 2a, 4a. From there, I can get it as 3a is equal to 5d. So I can replace 5d with 3a. 3a is equal to 120. So 5a is equal to 120. A is equal to 24. A is equal to 24 degrees. If A is equal to 24, 3 times 24 is equal to 5d. So from there, d is equal to, just for the purpose of doing the calculator, there is a simple calculations we can do without calculator also, just showing it out. So it is 3 times 24 divided by 5. So how much is that? 14.4. So D is equal to 14.4. So what is the value of D? 14.4. What is being asked now? Find the perimeter of the smallest sector. Perimeter of the smallest sector. If this is a sector, it may be the smallest one. So I want the perimeter of this one. This one is nothing but what just now we got 24 is the smallest angle. Radius is 5. So perimeter will be equal to radius plus r theta, length of the arc, plus radius. So which is 5 plus 5 times theta is 24, but it should be in radians. 24 divided by what it says, you have to convert into radians. 24 degrees, we should not be writing it out in degrees. So I write it as 5 times 2 pi by 15. 24 can be written as 2 pi by 15 plus r. So simplify this one. This should be giving you the answer 12.1. So I got 24 degrees. I convert that one into radians as 2 pi by 15. Now the next part. The first, second, and third terms of a geometric progression are 2k plus 3, k plus 6, k respectively. Given that all the terms in the geometric progression are positive, calculate the value of k. So first term is 2k plus 3, k plus 6, k. 2k plus 3, k plus 6, and k. So this is T1, this is T2, this is T3. So T2 upon T1 is equal to T3 upon T2. So k plus 6 upon 2k plus 3 should be equal to k upon k plus 6. So I will do k plus 6 whole square is equal to k times 2k plus 3. So it becomes k square plus 12k plus 36 is equal to 2k square plus 3k. So bring all the terms on one side. K square minus 9k minus 36 is equal to 0. So k minus 12 times k plus 3 equal to 0. So k is equal to 12, k equal to negative 3, but this is not possible. So k is equal to 12. Next, what has been asked? Sum to infinity of the progression. Sum to infinity means a by 1 minus r. Sum to infinity is equal to a by 1 minus r. So I need to know a value and r value. What are the terms if we know? The terms are 2k plus 3, k plus 6, k. 2k plus 3, k plus 6, k. K is 12, so this is 18. This is 2 times 12 is 24, 27. So common ratio, this is T1, T2, T3. Common ratio is T2 upon T1, which is 18 upon 27, which is 2 upon 3. And the first term is A. So it becomes 27 upon 1 minus 2 upon 3, which is going to be 81. Coming to the last question. The diagram shows the part of the curve y is equal to 4 root x minus x. The curve has a maximum point M and meets x-axis at O and A. Find the coordinates of O and A. Very simple. At A, x is a what it says. The y value equal to 0. So 0 equal to 4 root x minus x. So 4 root x is equal to x. 4 root x is equal to x can be written as root x times root x. Root x gets cancels. 4 is equal to root x. Squaring on both sides, x is equal to 16. So the point A is 16, 0. Coordinates of M. M is a maximum point. Maximum point means first derivative should be equal to 0. Find the first derivative. So many times in the papers I would have told you root x derivative need to remember as 1 by 2 root x. X derivative 1. So remember derivative of root x, so many times you'll be coming across, it is 1 upon 2 root x. Easy to remember. Should be equal to 0. So 4 upon 2 root x minus 1 equal to 0. So 2 upon root x equal to 1. Root x equal to 2. X is equal to 4. So x is equal to 4. So y is 4 root x minus x. 4 root x minus x. So 4 root 4 minus 4. So which is y is equal to 8 minus 4. Y is equal to 4. So what is the point of M? 4, 4. Find the volume obtained when the shaded region is rotated 360 degrees along x-axis, giving your answer in 5. So volume x-axis will be pi integral pi square dx. 4 root x minus x whole square dx. So I expand this one, it becomes 16x minus 2ab 4 root x times x plus x square dx. The limits will be from 0 to 16. 0 to 16. Pi integral 16x minus 8x to the power of 3 by 2 plus x square dx from 0 to 16. So it becomes pi 16x square upon 2 minus 8x power 5 upon 2 upon 5 upon 2 plus x cube upon 3 from 0 to 16. Lower limit is 0, no need to substitute only. So only need to substitute the upper limit. 8 x square is 16 whole square minus 16 upon 5, 16 to the power of 5 by 2 plus 16 cube by 3 minus 0 minus 0 plus 0. So simplify this one, you should be getting 136.5 pi. That's going to be the final answer. So that concludes the paper. See you in the next paper. Bye.